This is recitation 4, Flux and Gauss's law, problem 4. For problem 4, we will have conducting spherical shell. This is a conductor, conducting spherical shell. Inner radius A and outer radius B. A and B are given. We will put charge Q at the center of this spherical shell. And in addition to this, we will put charge plus, this is positive charge plus Q, and we will put plus Q2 on the outer shell of this, on the outer side of this spherical conducting shell. You remember that if we charge the conductor, the charge is on the surface. So plus Q2 is on the outside surface of this conducting spherical shell. We need to find charge density sigma everywhere. So first of all, we will consider the surface R equals to A. So we are on the inner surface of this spherical shell. What will be sigma? Sigma, by definition, is charge, let me put it right here. By definition, dq is sigma ds, where S is surface area. S is the surface area. If charge is uniformly spread, if charge is uniformly spread, then sigma is constant, and Q is just sigma times area, which means that sigma is Q divided by area. So at R equals to A, let's find sigma at RA. If I put charge plus Q here, this is a conductor. It has many free electrons. So these free electrons will be attracted to this surface by this charge plus Q. And they will build induced charge on this surface. What is the magnitude of this induced charge? So let's put here Q with question mark. What is this Q with question mark? To find what is question mark, we will use Gauss's law. Integral E dot ds of a closed surface is charge enclosed by this surface divided by epsilon naught. So I will consider Gaussian surface that is a sphere, imaginary surface, that is inside this conductor. So this is my imaginary sphere, Gaussian surface. It is between A and B, so it is within the conductor. Electric field inside the conductor is 0, so the left-hand side of Gauss's law is 0. 1 over epsilon naught, and then Q enclosed by this Gaussian surface is plus Q, and then plus Q unknown, Q with question mark. Since sum of them is 0, then Q question mark is just equal to minus Q. So we understand that the charge induced here will be exactly the same as charge Q, and I raise this question mark. So minus Q is built on the inner surface. Now I can write sigma. So sigma is charge divided by area. Charge built on this surface is minus Q, and the surface area surface area is 4 pi a squared. So we found sigma at RA. Now we need to find what is charge density at RB. R is now B. So let's think about it. Forget for a minute about this Q2. Just let's forget about Q2. What do we have here? We have plus Q at the center, minus Q is built on the inner surface. This is the conductor. It is neutral if we forget about Q2. So minus Q is built on the inner surface. Then plus Q will be left on the outer surface. So what is the total charge now on the outer surface of this shell? Plus Q is built here because minus Q was induced because of this charge at the center. We have plus Q and plus Q2. So what will be the total charge? Sigma will be equal to Q plus Q2 divided by the surface area, which is 4 pi b squared. So we found charge density sigma everywhere at RA and at RB. At RA and at RB. Now, imagine that Q2 is negative. How will your answer be changed if Q2 is negative? Which means that what I have here is minus Q2. I'll put it with different color. Minus Q2. We change the problem. So at RB, sigma is equal to, what is the total charge built on the outer surface of this shell at R equals to B? It is plus Q, still there, and then minus Q2, it's negative number. So negative charge, we just add these numbers. And I divide by surface area, which is 4 pi b squared. So if Q2 is negative, it just comes here with minus. We found sigma at all surfaces for this case, also if Q2 is negative.